Hi, it's Mr. Canada here, and today we're doing fractional indices. So, if you look, it's kind of everything we've done with both square roots and with powers altogether. So it looks really confusing, but we've seen when we have x to the power of n, or x to the power m, right? And we've seen the square root of n, or square root of x, sorry, not square root of n, square root of x with n there. So, the thing is this form, right, is x to the 1/2 for a root, or for a square root, right? And then, right, we have x to the 1/3, would be the cubed root of x, and so on. So, x to the power of 1 over n is equal to whatever the root is for x, right? So that's basically what it's kind of trying to bring together. So the second part of the equation, this little guy right here, actually I'll do it in a different color, we'll do it in blue. Okay, this little part right here, okay, is just saying that it doesn't matter, we can put our indice on the outside, or we can put it on the inside. So we can move that in between, as long as it applies to all the terms. So this m doesn't actually affect our n, right? It'll affect our overall value, but it won't affect our overall m. Okay? So we have this combination, and a lot of the times it's actually going to be more advantageous to work in this form. Okay? So understanding that m is still our power, n is the value. If it's a square root, it's 2. If it's a cube root, it's 3. If it's a fourth root, it's 4, and so on and so forth. Right? So we're going to use that to simplify our expressions using a combination of our laws of indices. So there's no real guidelines for these ones per se, but you just want to combine them like normal. So we're looking along. What can we do? Well, we see this multiplication, so we check same base, same base. Okay, so then we can apply our law of indices. Right, so we have x to the 3 over 2, and we're going to add on this 1/2, right? So we're just adding our indexes. So we get a to the 4 over 2, which we know gives us a squared. So there you go, something really confusing gave us something quite nice. Example 2, well, what happens? We have a mix between this first form and the second form. So anytime, leave the operations alone and just get it in the same form so we can combine them easily. So we have y to the 7 over 2, I'm just going to leave as that, divided by, and here I'm going to do y to the 1/2. Okay, so now it doesn't matter if you want to leave it in this form or change it to the algebraic form. I'm going to choose to just leave it here because I know with division, if they're the same base, I can simply subtract their indexes. So they have the same denominator in our power, so we can just simply subtract our numerators of our fractions. So 7 minus 1 is 6 over 2, which 6 over 2 is going to simplify to 3. Okay, right. So what about when we have something like this, where we have a fractional index with our power law? Well, nothing's changed. We just have a base, and we have an exponent, or a power, and another power. We just have to multiply those together. So here, we're just going to go 7, 4 times by, well, that's times by 3/4. So we know that that is 7, we can say that's 7 to the 4 over 1 times by 3 over 4, and we have a 4 on the top, 4 on the bottom, so we can just get rid of it, and at the end we're going to write this as 7 to the power of 3. Okay. So simplifying you don't always have to get a number out. With numbers, though, you could take this a little bit farther, right? Because 7 times 7 is 49. 49 times 7 is 343. Okay. So you can simplify number answers all the way. It'll usually tell you simplify into index form, simplify completely. Simplify completely would be getting back your number. Okay, and last one. Something that looks like, okay, a combination of everything and doesn't really look nice. So I'm going to choose to just first off convert, and then I'm going to write a little nicer. So dealing with my first term, this means I'm going to have x to the power of 3 still. But what is it? Well, our square root is 2. So divided by 2. And then we're dividing this x to the, well, it's squared. And then this time our root is the cubed root, right? So we have to put the 3 on the bottom. So they have the same base and it's a division, so we're just going to subtract, right? So we have x to the 3 over 2 minus 2 over 3. Now, I put this in here to kind of stump you at this point if you're kind of thinking, well, I don't know what to do. Well, it's just fractions, right? It's just a fraction up there. So I'm going to write this x nice and big. That way I can kind of write my fractions up in my indices, indice, a lot nicer. So what exactly do I have to do? Well, I'm just going to multiply that to there and that to there, right? So we're just going to multiply. And we'll get x to the 9 minus 4 over 2 times by 3. Because we're just multiplying everything by everything we don't have, right? So I sometimes refer to this as cross multiply and divide. Other times it's just take kind of the easy way of balancing fractions, finding equivalent fractions. So bringing this all together, 9 minus 4 is what? 5. 2 times 3 is 6. So you have x to the power of 5, 6, all nice and simplified down. Okay, so here are 9 questions for you to give a go. I'd say the first lot of them are kind of more straightforward. If you get stuck on the end ones, don't fret. I just wanted to put in a whole bunch of different ones that you might kind of come across. So pause the video. When you're ready, press play, and we'll go through the answers. Okay, so here we're going to just add our bases. So we can write this as 6 over 2, just to have it as the same. So this is going to be y to the 7 halves. Next, same thing, we're just adding. So here, I'm going to turn this into a decimal, right? Make it my life a little bit easier. So we are going to add our indices, 3.5 and 1.5 is y to the 5. Next, we have this, and it looks all kind of confusing. I'm going to turn it all into this form, I think, because that looks a lot nicer. So here, 4y, and this is to the 3 over 2, as that 3 is on the outside of our square root, timesing by 2y to the half, timesing by, well, here we're going to take the square root of 4 first, so we're going to have 2, and then that's just going to be y, because we can take the square root of these parts individually because they're all perfect squares. Square root of y squared is just y, square root of 4 is just 2. So, I'm going to kind of break up this one a little bit more on the front, because I can bring that 4 out there, right? So here, I can take the square root of 4, which is 2. 2 cubed is 8. So you get 8 y to the 3 halves times by 2y to the half times by 2y to the 1. So 8 times 2 times 2, 8 times 2 is 16, times 2 is 32, and then we're just adding all these indices. So 3 halves and a half is 2, and 1 is 3. Okay, that one's quite difficult, so moving on to something a little bit nicer. Y to the 3 halves divided by y cubed. Well, let's turn this side to a fraction so we can have the denominators the same, and then we can just subtract the indexes. So we have 3 halves minus 6 halves is negative 3 over 2, right? And then if we want to state that actually a little bit better, we'd want to get rid of the negative, so we could say 1 over y cubed 3 halves. So I'm just going to rewrite that. 1 over y to the 3 halves. So you can see why it's sometimes better to actually do decimals if you can't really write the index. Here, let's just change this into a nicer form. So m to the 2.5 divided by, well, m to the 1 is 1 over m, right? And we know that, well, if we have a fraction over a fraction, we invert and multiply. N to the 2.5 times by, because this is like some people talk about KFC when they're got to divide by a fraction, they turn it to a multiply if they flip. So here, we're going to change this to m times m to the 2.5, which is m to the 3.5. Okay, over halfway done. Look at 6. So we're just going to go 2n to the 3 halves. Right? And then we're dividing by, well, what is this? This is n to the half, right? And that's times, so this, we're going to just say that this is 4n to the half divided by n squared. We're just switching that n to the bottom. And then we're going to just say 3 halves divided by, let's just take care of the first division first. So we're just going to keep our 4. A half minus 2 is n. A half minus 2 is, well, negative 3 halves. So, what can we do here? Well, here we're subtracting a negative, which is going to make it positive. So, 2 divided by 4 is simply 1 half, right? Sorry, I dropped my n over here. 1 half, and then we have to take 3 halves and take away 3 halves, so we get n to the 6 halves, which is n cubed. So 1 half n cubed. Moving on to question 7. Okay, so first off, we want to get rid of this bracket. So we're going to leave that m, and I'm just going to say it's multiplied by, well, square root of 16 is simply 4. M squared to the half is just m. So in the end, we're going to get 4m squared. Here, looks really nasty, right? So what exactly can we do? Now, this is quite an advanced problem. I'm going to just kind of run through this a little bit slower. So we're going to break this up into our top and bottom, because we can break up a square root when it's division, right? Just like we can with multiplication. Because this will allow us to see what we can maybe mess around with a little bit more. Okay? So right away, what do I see? I see I have an x squared term on both bottoms. So I'm going to change this negative 1 into root x squared over root x squared. So that's a little bit of a trick some of you may not have seen previously. So we're going minus root of x squared over the square root of x squared. And this is equal to, well, square root of 1 is 1 over x squared. So, one thing we can do is, since we have the same denominator in it all, it doesn't matter if we just get rid of it, right? So, that was a nice little simplifying trick that some people may have struggled with. So here, I'm just going to do this in red just to see what we have. Minus x squared, right? And this is equal to 1. So let's just apply those square roots that you really could have almost done at the beginning, but it's just a different way of simplifying I wanted to show you. So y squared minus x squared is equal to 1. So I was just thinking, in this last step right here, I gave the wrong reasoning why we could cancel that all out, but it still works because we just times by root of x squared everywhere, and so every single other one cancel out, and we were left with just this one here in the middle. Anyways, continuing on. Now we have this y squared minus x squared is equal to 1, and we can kind of just leave it like that. Lastly, question 9. Let's look at this one. Let's just kind of start to expand some of our brackets, I think. So here, I'm just going to say that this is s to the 3/4. That bracket was just not needed. And then we have this, we can expand. We have s squared plus 2s plus 1. Now I noticed since it was a squared thing, I know that I was going to get s times 1, which gives me 1s, and then s times 1, which gives me another 1s, and then 1 times 1 gives me 1 on the end. So I get s squared plus 2s plus 1. So now let's multiply this into each of our terms, just like we would do with normal bracket expansion. So our first one, we get, what do we get? We get 6 over 4, right? Here we get 2s to the, well, we have s to the 1, which is 4 over 4. So 4 over 4, then plus 3, so we get 7/4. And then plus s to the 3 over 4. Okay, so that one, all we can really do is simplify our front a little bit as 3/2 plus 2s to the 7/4 plus s to the 3/4.